2 times 3 is 6 times 5 is 30. True? Okay, then I'm going to go down to prime factors. Okay, this is not 8. I said we're going down to prime, so I could rewrite 6 is 3 times 2, and 12 could be 2 times 2 times 3. You guys follow me on what the primes are? Okay, so then just looking at this, square root and square root inverse operations. This is not in a book anywhere. This is just my notation. Every time I have a double, the square root of 3 squared is 3. The square root of 2 squared is 2. Okay, so I've got 30 times 3 times 2 is 6. So 30 times 6 is 180. Okay, 18. Okay, I'm feeling lazy. Can we just write 18 as 9 times 2? 50, we could do 25 times 2. And 98, 49 times 2. Okay, here's a little hint. Once they give you one radical that's left over, they tend to leave that as their leftover so they can add like terms. Okay, square root of 9 is 3. Square root of 25 is 5. Square root of 49 is 7. So I've got 9 square root of 2 plus 10 square root of 2 minus 7 square root of 2. 9 plus 10 is 19, minus 7 is 12. Okay, 27 I can rewrite as 9 times 3. 48 I can rewrite as 16 times 3. 75 I can rewrite as 25 times 3. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Okay, so we've got 12 square root of 3. Oh, minus 12 square root of 3. Okay, 12 minus 12 is nada. Okay, so 0 plus 10 is 10. Okay, so this time I'm going to have to distribute. So 2 times 3 is 6. Square root of, okay, I'm going to go down to primes again rather than multiplying out 5 times 15, because I know 15 is 5 times 3, so I'm just going to write 5 times 5 times 3. And 2 times 2 is 4. Okay, so my perfect squares are the 5s. So I have 6 times 5 square root of 3 minus 4 times 5 is 30 square root of 3 minus 20. That one thing, so I took all of their problems and put it on one worksheet. So that's why this one's so long. This one's not too bad. 3 times 12 is 36. That's a perfect square. 12 is not a perfect square though. I'm going to go 2 times 3 times 3. What? 6 is not 3 times 3. 6 is 2 times 3. Hello. Okay. Other than that, we're all good. Okay, 4 times 3 is 12, square root of 4, and 4 square root of, okay, that's going to be 12 again, so I'm going to do 2 times 2 times 3 again. Okay, I should have written this one as 6 times 6, so that's what I'm going to do. Okay, so square root of 36 is 6. Square root of 2 squared is 2. And I have a square root of 3 left. Square root of, we can write that as 2 times 2 if we're going to do it that way. Square root of 2 squared or square root of 4 is 2. Square root of 4 or 2 squared is 2 again. Okay. So I've got 12 minus 6 square root of 3 plus 24 minus 8 square root of 3. 12 plus 24 is 36. Negative 8, negative 6 minus 8 is negative 14. Is 6. Wow, that's a really ugly 6. I'm just going to go ahead and write primes again. 3 times 6 is 3 times 2. 2 times 4 is 8. So square root of 3 squared is 3. And square root of 3 squared is 3. So I have 18 square root of 2 minus 24. Okay, 12, I'm going to rewrite as 4 times 3. 5, I'm going to rewrite as 9 times 3. And 25 is a perfect square, so I'm happy with that one. Wow, if I can copy it down, it'd be great. Okay, square root of 4 is 2. Square root of 9 is 3. And square root of 25 is 5. Negative 3 times 2 is negative 6. 5 times 3 is 15. 8 times 5 is 40. Negative 6 plus 15 is 9. We can do 28 is 4 times 7. 63 is 9 times 7. I'm guessing if we take 175 divided by 7, it works. It's 25 times 7. Square root of 4 is 2. Square root of 9 is 3. Square root of 25 is 5. 2 times 2 is 4. 3 times 3 is 9. Oh, people are talking, so I have to stop. Four minus 9 is negative 5, plus 10 is 5. For a while, so throwing this in. 4 times 3 is 12. Square root of 24, can we just rewrite 24 as 4 times 6? 3 times 2 is 6. 12 times 3 is 36. That's a perfect square, that's nice. Square root of 4 is 2. And we have 24 square root of 6 minus 36. That's an ugly 24. So we have 10 square root of 20. Can we just go ahead and write 20 as 4 times 5? And 6 square root of 2 times 2 is 4. Square root of 4 is 2. Square root of 4 is 2 again. And they're not like terms, we can't combine them. Okay, 4 times 3 is 12. 20 times 2 is 40. Perfect square factor of 40, 4 and 10. Is that all right if we skip writing down the square root of 40? Just go to 4 times 10? Okay. And 4 times 2 is 8. Square root of 100. Perfect square. Nice. Okay, so square root of 4 is 2. And square root of 100 is 10. So we have 24 square root of 10 minus 80. Not like terms, can't combine them. Okay, we're distributing again. 3 times 5 is 15. 2 times 2 is 4. 3 times 4 is 12. Okay, 2 times 6 is 12. I'm going to rewrite square root of 12 as 4 times 3. Square root of 4 is 2. Square root of 4 is 2 again. So I've got 30 minus 12 times 2 is 24. 20 we can rewrite as 4 times 5. 125, 25. times 5. And 45, 9 times 5. Square root of 4 is 2. Square root of 5 is 5. Square root of 9 is 3. Negative 3 times 2 is negative 6. 2 times 5 is 10. 5 times 3 is 15. Negative 6 plus 10 is 4, plus 15 is 19. Distributing again, so we've got 3 times 4 is 12. 3 times 12 is 36. 3 times 3 is 9. And 3 times 12 is 36 again. Oh, those were like terms. I could have combined those two first. I didn't. Oh well. Square root of 36 is 6. And 12 times 6 is 72. 9 times 6 is 54. No radical this time. They all went away. Okay, last odd. 4 times 5 is, whoa, not 4 times 4. 4 times 2 is 8. 5 times 10 is 50. So let's just do 25 times 2. 4 times 3 is 12. 5 times 5 is 25. Square root of 25 is 5. Square root of 25 is 5. And we're done.